Hey guys, it's Miss Richardson. I just wanted to show you some problems that will be coming up for you in the lesson called sequences. So hopefully you guys are following along with me in your example problems. All right, so we have looked at this year, we have looked at linear functions, which means when you graph a table like these, it will form a straight line. The numbers or the order pairs will form a straight line, and also nonlinear functions. So basically, as long as you see a consistent pattern, you'll know that a function is linear. For example, if we think of our formula, the function of, wait, hold on. My pen always turns off. So basically, to find the slope, we would do y2 minus y1 is divided by x2 minus x1, right? So the second y value minus the first y value over the second x value minus the first x value. So basically 17 minus 13 over 7 minus 5. So we get 4 over 2, which is 2. Now if that is consistent throughout the whole table, we'll know that it's a linear function. So let's try it down here. What's 29 minus 25? 4. 11 or 13 minus 11 is 2. So we know that this graph is linear. We could try all the points, but the way that's written, since our x is increasing by 2 and our y's are increasing by 4 consistently, that one's easy to tell that it's linear. Now look at letter A. Our x values are not increasing by the same digit. So from 2 to 3, I would increase by 1, but then it goes plus 2 and then plus 3. So we're going to have to use a little bit more math. So we'd find the same thing. We could do our second y value minus the first y value over 3 minus 2 is 1. So that's 2. Well, let's try a different place as well. 18 minus 12 is 6. 8 minus 5 is 3. So 6 divided by 3 is also 2. And if I tried the other two values, I would see that this is also linear. Even though my x values aren't increasing consistently, the rate of change is consistent. Now with this graph on the right, we see that there is a consistent change here, plus 1, plus 1, plus 1, plus 1. But this is plus 5, and this is plus 8, and this is plus 9, so on and so forth. So because the rate of change is not consistent, that means that our graph on the right is not linear. In fact, it's nonlinear. All right, now we're going to look at a couple of different types of formulas. If you have an explicit formula, that's when you can multiply each term by the same factor, or you can add each term by the same addend. Now a recursive formula, that's when the next term relates to the previous term. So like if you have a function where each time the y value doubles, well the next y value depends on the previous y value, right? All right, so let's look at how to read this. So basically this is saying the function of 0, so in this case when n is 0, the function of 0 is 100. It gives us our first value, our first term. So then it says, all right, to find the function of any number, you're going to multiply 0.7 or find 70% of the previous, this means the previous quantity. So if I want to know what the function of 2 is, I'm going to multiply 0.7 times the previous quantity. Well, the previous quantity was 100. And then I'm going to add 50. Okay? So the function of 2 is equal to 70% of the function of 1 plus 50. So in my calculator, I'm doing 0.7, well, I don't need a calculator. 70% of 100 is 70, and 70 plus 50 is 120. All right, so find the third function, the function of 3. or the value, I should say, of the third, or find the third term would be an easier thing to say. I'm going to find 70% of the previous, this means the previous term. Well, the previous term is 120, and then I'm going to add 50. So 0.7 times 120 plus 50 is 134. Well, how do I find the third term? Well, I'm going to find 70% of the second term, and then I'm going to add 50. And I'm just putting this right in my calculator, 143.8. I'm going to find 70% of that number, and then I'm going to add 50. So I got 150.66. And then 70% of that number plus 50 is 155.462. Now, if I want to see what is the common ratio, how are these numbers increasing? So basically, I'm just going to divide. I'm going to take a number like this one, and I'm going to divide that number by the previous number. So I'm going to divide 155.462 by 150.66. And I get 0.103. And if I divided 150.66 by 143.8, I'm going to get the same ratio. If I did it again, I'm going to get the same ratio, going all the way back to the beginning. So if you're ever asked to find the common ratio, you can divide one number by its previous number. Okay? All right, so let's look at the second problem, or this one down here. So basically, what does this right here tell us? This says that the function of 0, so when n is 0, it's equal to the function of 1. So these two are the same number. And both of those is the number 1. So the function of 0 is 1. The function of 1 is 1. Now it's saying, what about the next values? The next values is, so let's say I want to know what is the function of 2. So if I want the next one, so this is saying what I want the next function, then I'm going to take f of n. So I'm going to take f of n, so the function of 1 plus, I'm going to add it to the previous, well, the previous one, whoops, that should be a 1. The previous term was 1 also. So basically the function of 1 plus its previous term, 1 plus 1 is 2. All right, so now to get the next term, so to get the third term, so the third term, I'm going to take the function of 2, which is 2, and I'm going to add it to the previous term, which was 1. So basically, I'm adding 2 plus 1, and I get 3. Well, the next one is going to tell me the same thing. I'm going to add the 2 previous terms. So 2 plus 3 is 5. And then for the next term, I'm going to add 3 plus 5, and I get 8. So that one was a little tricky, you guys. All right, so these are 2 words that you're going to need to be familiar with, the word arithmetic and geometric, all right? So if you have a set of numbers that increase or decrease by the same digit, that's arithmetic, by either adding or subtracting. So to get from one term to the next, if I add or subtract consistently, that's arithmetic. Now, geometric means I'm either multiplying or dividing by the same digit. So for example, to get from 200 to 180 to 160 to 140, it's consistently adding -20, right? You could say subtracting 20, but the same thing is adding a -20. So really they want us they really want to know what we're adding and what we're multiplying, okay? So this is arithmetic because we are consistently adding -20. What about this one? How do I get from 2 to 10 to 20, 20 to 40, 40 to 80, 80 to 160? Well, each time we're multiplying by 2, correct? So the ratio, so here we would say the common difference, is negative 20. Here we would say the ratio, the common ratio is times positive 2. Okay, so that makes it geometric because we're multiplying by 2. So now let's look at these. Are these going to be arithmetic or geometric? So how do I get from 5 to negative 15, negative 15 to positive 45, 45 to negative? So aren't we multiplying by negative 3? The common ratio is negative 3, which means it's geometric because we're multiplying each term by negative 3. Look at number 2. How do we get from 120 to 95, 95 to 70, 70 to 45? Well, what are we doing? We are subtracting 25, right? So it's arithmetic, and the common difference is negative 25. It's arithmetic because the common difference is negative 25. All right, let's look at this one. How do we get from 3 to negative 5, negative 5 to negative 13, negative 13 to negative 21? Well, aren't we subtracting 8? So that means it's arithmetic because there's a common difference of negative 8. All right, and then number 4, how do we get from 120 to 60, 60 to 30, 30 to 15? Well, we're not adding or subtracting. We are multiplying. What are we multiplying by consistently? Our common ratio is 0.5. Okay. All right, so let's look at an arithmetic explicit formula, and then we're going to look at a geometric explicit formula. So the very first thing it says is you need to identify the first term. Then you're going to identify the common difference. So here we have a word problem. It says the city's convention center has been bringing in chairs. They are setting up in rows in front of the stage, period. The first row has 10 chairs in it. So there's our first term. The first row has 10 chairs in it. Each row has 2 more chairs. There's our common difference. Plus 2, plus 2, plus 2. Then the row in front of it, how many chairs will be in the 24th row? So our first term is 10. Our common difference is 2. And we're looking for the 24th term. So to find the 24th term, we're looking for the function of 24. We're going to use our formula. We're going to use our first term plus 2 times the previous term. All right, so our first term is 10. We're going to add 2 times, not the 24th term, but we need the previous term. Well, the previous term was 23. So we multiply 2 times 23 and we get 46. So this tells us that our, in our 24th row, we have 56 chairs, okay? All right, so that's our arithmetic explicit formula. You just plug in the information that they give you. Now we're going to look at a geometric explicit formula. Same thing, kind of. We're going to identify the first term, and then we're going to find our common ratio. So what are we multiplying by? So here we have a list of ordered pairs. So the first term is 75, the second term is 72.75, so on and so forth. So the first thing we want to do is identify that first term, which is the function of 1 is 75. And now we want to know what is the common ratio. So if I wasn't sure, what I would do, guys, in my calculator, I would take this second term and I would divide it by the first term. So 72.75 divided by 75 is 0.97. And then just to double check, I'm going to take third term and I'm going to divide it by the second term. 70.57 divided by 72.75 is 0.97. Now that one is, it's not a terminating decimal, but it's really, really, really close to 0.97. So that's my common ratio, 0.97. So basically think about that. If we're keeping 97% of our number, whatever these numbers are, doesn't that mean we are decreasing by 33% each month? Uh-oh, that should be 0.03. That's a mistake. I'll fix it before I send it out to you. So if we're keeping 97% of whatever this is, it means it's decreasing by 0.03, 3% each month, right? So finally, the question is, what is the 12th term? So we want to know what is the function of 12. We want to know what the 12th term is. So our formula tells us to take the first term, which is 75, multiply it by our common ratio. So our common ratio is 0.97. And we want to know the 12th term. So we have to use 12 minus 1, which is 11, as that exponent. So 12 minus 1. So n, that's the term we're looking for. So the 12th term means we're going to take 12 minus 1 and raise it to the 11th power. So we're going to multiply 75 by 0.72, and we find out the 12th term would be 53.65 miles per hour. So I left off this scenario of what's happening here, but that's the 12th term based on the formula. All right, so let's look at this table. It says the amount of medication in a patient's bloodstream is listed below. So over time, the amount of medicine in your bloodstream is going to decrease, and that's what's happening here, right? These numbers are going down, but not arithmetically. They're going down geometrically. So we want to know, what is the first term? Well, the first term is 180. Oh, and it asks after 24 hours. So we are looking for the function of 24. That's what we're looking for, the function of 24. So it says we're going to take the first term, which is 180. We're going to multiply it by our common difference. Well, what is our common difference? Or not difference, I should say ratio. So take the second value, which is 156.6, and divide it by 180. And I got 0.87. 0.87. And I'm going to try it again just to double check. 136.24 divided by 156.6. And I got very, 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 very close to 0.87. So that's what I'm going to go with. So if something is decreasing by 87%, if something is decreasing by 87%, basically what's happening is it's decreasing by 13%, right? It's not decreasing by 87%, it's decreasing by 13% because we're keeping 87% of it. So 156 is 87% of 180. We're keeping 87% of it. So it's decreasing by 13%. All right, so anyway, now we know our common ratio is 0.87. And if we want to know the 24th term, we're going to raise it to the 24 minus 1 power, which is 23. We're going to raise it to the 23rd power. So in my calculator, I multiply 180 times 0.87 raised to the 23rd power. And my answer is about 7.315. So the function of 24 is about 7.315. All right, you guys, I hope you're trying these with me and see if you get the same answer. All right, Isabella posted a video online of her dog playing the piano. Wow. The graph shows the number of views the video receives each day. So on the first day, it got 1 view. On the second day, it got 5 views. On the third day, it got 25 views. On the fourth day, it got 125, we're wanting to know how many views it got on the 10th day. So we're going to use our formula right here. We want to know what the function of 10 is. So we're going to identify our first term. So our first term is 1. We got 1 view the first day. Times, what is the common ratio? What's 5 divided by 1? What's 25 divided by 5? What's 125 divided by 25? The common ratio is 5. Raised to the what power? We want to know the 10th day, so 10 minus 1 is 9. So we want to know what is 1 times 5 to the 9th. Woo, that is a big number. So the function of 10, guys, if this exponential pattern continues, we're going to have 1,953,125 views. That got big fast, didn't it? From day 1 to day 10, over 1 million views. Detective McMurlock was rewarded $1,000 for his work with sequences. Wow, maybe we will be too, you guys. He placed the money in a savings account modeled by the function 1,000 times 1.03 raised to the x power. Prove that the function of x is a geometric sequence, an arithmetic sequence, or not a sequence at all. All right, well, we're just going to plug in these values for x and see what happens. So when x is 0, what's anything to the 0 power? 1. And what's 1 times 1,000? 1,000. All right, what if x is 1? What's 1.03 to the first power? The answer is 1.03. And so 1,000 times 1.03 is 1,030. All right, what is 1.03 raised to the second power times 1,000 equals, whoops, 1060.9. All right, 1.03 raised to the third power times 1,000 is 1092.727. And then finally, the fourth one, 1.03 raised to the fourth power times 1,000 is 1125.50881. Okay, so we want to know if it's geometric, if it's arithmetic, or it's not a sequence at all. So I know it's not arithmetic because 1,000 plus 30 is 1,030, but 1,030 plus 30 is not 1,060.9. So I know it's not arithmetic. So the only other thing I want to do is find if it's a consistent increase. So I'm going to take 130 and I'm going to divide it by 1,000. And I get the common difference is, or common ratio is 1.03. All right, and then I'm going to take 1060.9 divided by 1030. And I get, guess what? 1.03. I'm going to try it again. 10.92.727 divided by 1060.9 is, guess what? 1.03. So anyway, I think I have proven that this is geometric. So the common ratio is consistent. Okay. All right, so now it's looking at these 4 sets of numbers, and the question is, are they arithmetic or geometric? Find the common ratio or difference. I want you to pause the video, and I want you to try these on your own, and then I want you to come back and check your answer. All right, so the first one is arithmetic. The common ratio is +2. The second one is geometric, because the common ratio is times, or the common ratio, yeah, I said that right, didn't I? Is times 2. All right, the third one is geometric, and the common ratio is times 0.5, times 0.5. All right, so what is our common? So first of all, we know that this is not, or do we know that this is not arithmetic? Is it going up by 0.38? To 4.38 plus 0.38 is 76 plus 0.38. Oh, it is. It is arithmetic. So this one's arithmetic, and the common difference is 0.38. All righty. Hopefully you got all those right. Amanda exercised for 10 minutes every day in the first week. So I'm going to do Amanda. I'm going to make Amanda a chart. So the first week she did 10 minutes. The second week she did 20 minutes. The third week she did 30 minutes. And the fourth week she did 40 minutes. So I know that Amanda is arithmetic. So it's just adding 10, add 10, add 10. Now Billy Bite, the first week he did 5 minutes. The second week he did 10 minutes. The third week he did 20, and then he did four weeks he did 40. So this is increasing by times 2. This is plus 10. So it says, which statement best describes the methods used by Amanda and Billy? All right, let's see what our choices are. Both Billy's and Amanda's methods are exponential. No. Billy's method is linear. Is it increasing by the same amount? Plus 10, plus 10, plus 10? No. So Billy's is not linear. Amanda's method is linear because the number of minutes increased by an equal. Yes, that's what it is. It is choice number 3. And then both of theirs are exponential. No. Amanda's was arithmetic, not exponential. Okay? All right, a store had 250 bottles of water. Each week, 40% of the bottles were sold. So guess what? We got to keep 60%. So if we sold 40%, we got to keep 60%. And 48 new bottles arrived in shipments. So let's see what would happen. So the store started out with 250 bottles of water, right? The first week we sold 40% of that number. So what does that mean? It means that we kept 60% of it, plus we got 48 new bottles. So at the end of the first week, 250 times 0.6 plus 48 bottles. So at the end of the first week, we had 198 bottles. Well, at the second week, we get to keep, we're not going to find 60% of 250 anymore, are we? We're going to find 60% of 198 times 0.6, and then we get to still add our 48 new ones. So 198 times 0.6 plus 48 is 166.8. Of course, you can't have 0.8 of a bottle, but we're just doing the math, right? And so each week, you're finding 60% of the previous number. So now look at the choices on the bottom. Which one tells us that we're going to take our previous number, we're going to find 60% of it because we're keeping 60% of it, and then we're going to add 48. So it looks like it's going to be this one, doesn't it? You take the previous answer, you take the answer before it, find 60% of it, and then add your 48 bottles. And if we use this formula every time, if we continued with our graph, we're going to know that that's the formula. That's how we're getting the next number. Okie doke. All right, let's look at Jill. Jill's been watching the squirrels that live in her neighborhood. The number of squirrels changes each week. So the first week she has 8 squirrels. Second week she sees 12 squirrels, then 18, then 27. Are these increasing by the same number? Plus 4, plus 6? No, these are inconsistent. So basically what we're going to do is, since we have a chart, we can just take our values and plug them in here. So if n is 1, this is 1. 1 minus 1 is 0, and anything times the 0 power is 1. Does 12 times 1 equal 8? 12 times 1 equals 8? Nope, that's not right. All right, let's try the second one. What about if we're finding the function of n, or 1? So 1.5 times 1, or raised to the first power is 1.5, and does 12 times 1.5 equal 8? Nope, it doesn't. All right, what about 1 minus 1? 1 minus 1 is 0. Anything to the 0 power is 1, and does 8 times 1 equal 8? That one's probably a keeper. But let's see the next one. So if n is 1, 1.5 to the first power is 1.5, and does 1.5 times 8 equal 8? No, it does not. So that one was easy because you just plug in the value that they give us into the formulas, and we figured out what the answer is pretty quickly. All right, EJ, I think, is this the last one? Good. All right, EJ has shown that a function, the function of x, grows by 12% for each unit of the domain. What does this prove? So if the first week, I'm just making up something, if the first week he had 10, and the second week it grew by 12%, well, 12% of 10, so 10 times 1.12, it would be 11.2. Well, then the third week it would grow by 112%, basically 112%, right? Because it keeps its own value and then adds 12%. The fourth week it would be 112% of that number, which was 14.04929. And then if I wanted to see if these have the common value or the common ratio, I could divide each number, the next number by the previous, and guess what? The common ratio is going to be 0.12 every time. 11.2 divided by 10. Well, it's 1.12. Yep. So guess what? It means it's geometric. I love that option. It doesn't prove anything. Nothing. It's funny. All right, Fiona has proved that a function is an arithmetic sequence. So what does that mean? It means that, well, it's not a common ratio if it's arithmetic, right? It's a common difference. That's what it means. You'll find a common difference. So it's letter A. All right, guys, that was a lot of math, but hopefully, I hope that helped. I hope it didn't confuse. So anyway, if you need some help or anything from me, just reach out to me. Thanks, guys.